So we're ready for the next phase of this plane making project, and we're going to work on the fitting the wedge to the blade and the body of the plane. I got a few jigs that I use. You'll be able to see that. You'll be able to see my process. The next plane that's part of this series, which will be the round plane, goes through the same steps. So I'm not going to film that and show that to anybody because it's the same process. It's exactly the same steps. So we'll get into the rest of it right now, and you'll be able to see how I do it. Jigs that I use, I have a jig that I use to shoot the edges of the wedge. So after I put a 10-degree taper on the blanks, I have a 5/16 wedge pocket. I have this roughed out to 3/8. And when I'm ready to taper it, I'll put it in this jig right down here and then shoot the edges of it with my, I guess you call this bench plane. So that's how I do this. And then when I want to trim the thickness, I use this jig, and it's got a little button set in it, and then the wedge just gets held in there by friction, and if need be, if I have to come in from the other direction, I can flip it over, flip the entire jig over and come in from the other direction. So right now these are screwed down, so no clamps or anything will interfere with the way the plane passes over it. And also on this one, what I do is I will, because sometimes it's difficult to hold and pass the plane, so then I'll clamp it. I have a clamp ready for this. And then what I do is I'll trim the wedge, go right to the plane. The plane is right here, and back and forth I have all my floats right here at the end of the bench. And I just tuned up all my planes, so it's really not much of a big deal. I don't even know if there's a whole lot that I can film. And I also have my calipers here, and what that does is that helps me figure out, when I'm trimming the thickness of the wedge, where the high spots and the low spots are, because I can't rely on my hand to just keep passing the blade over. I don't want to put like too much of a low spot in one direction. The idea is to leave the wedge heavy enough, well, small enough so that it passes into the wedge pocket, but heavy enough so that there's not a lot of slop, because you're relying on this wedge to hold the blade in place and resist all the pressure that the cut makes against the blade. So the first thing that I like to do is I like to get the thickness to where it'll go. Let's see. Alright, so this end is already a little heavy. It's not a big deal. slight twist in the pocket. So I'm going to take out the high spot. So there's this wedge pocket got a little bit away from me. It's a little bit wider than I wanted, but it'll work. So I'm resisting the temptation to put a lot of muscle behind anything because I think I'm real close, and I don't want to start creating too much of a low spot, and then I got to open the whole wedge pocket open again. I don't really want to do that. Okay, so that's a pretty good thickness. So now I can put the blade in there and start tuning the blade and the wedge together. So let me put this looks. Okay. So the process from here on in is basically back and forth. So I just created a good line between the back of the wedge and the face of the blade. So I know that that's straight. And now that I have pressure on the blade, I can see where all the high spots are on the bed of the plane. So I'll reach in there and trim that. And it's the same process for every aspect of the opening. So it's a gradual process of eliminating all the gaps and all the alignment, and I do all that right here. So basically did the work on this jig, the thickness jig is done, and everything from here on in is the tapering to get the 10-degree taper correct, and also fitting this blade now into the body of the plane with the pressure of the wedge at the same time. So I'm really not going to film any of that. There's not a whole lot to see, but that's the process. These are the jigs that I use. It's a lot of back and forth. You're basically tuning it. So it's back and forth, and that's why I do it. I do everything all here at one time so that I can jump back and forth. And that's also the other reason why I pick that point in time, which is at the end of the previous video, where it doesn't pay for me to pursue any more work in the body of the plane without the wedge. So that's where I like to stop and then transition to this work and begin the tuning process. So I'll wrap this part of the video up and then we'll move on to something else. I have the wedge fitting pretty good. And now what I'm going to do is I'm going to use my template, which I used previously in the other hollows and rounds. And what I want all the wedges to be the same profile from the top of the plane up. So now that the wedge has been fitted to the blade and both of them have been fitted to the body of the plane, now what I'll do is I'll just place this template up against the blade and up against the body of the plane, and then trace it out. This is a shape that I like, and it's common to most of the planes that I've built. Okay. Now, okay. So let's see what we got here. And I just cut this shape out with the coping saw. Check it for square. Looks pretty good. I'll hit it with some sandpaper and tune it up. It. So on the tip I have a 20-degree taper, and the point of the taper is set about 3/8 of an inch from the face, the cutting edge of the blade, above the blade. It's above the blade, it's holding the blade down, but that gives enough room for the curl to develop. And then this has been planed, this face on the taper has been planed, and you can wax this to get it smooth so that when that chip comes up the blade and hits this taper, it's nice and smooth. There's no spaces in here. This all has to be tight where it fits against the blade and the upper edge of the wedge pocket. There's no spaces in there so that it doesn't jam with the curl. So, and as you can see, it took me a bunch of hits with the back end of the hitting the back end of the plane to loosen this wedge. So I really like the way it fits. And let's see, we're going to set it again. And you probably can't hear it on the camera too well, but these also sound really good. That's got that solid sound to it where it's stopping, it's hitting all the points. Every point of resistance is being accumulated inside the body of the plane. And then, as you can see, it fits really tightly in there. And that's what reduces the chatter. And also what I also did was, because I have a heavy light above the camera, is I held the plane up to the light, and I'm looking through and seeing if any light will pass through here, if there's any spaces. I'm checking to make sure that this is not tipping, that there isn't a high spot way up inside here. Trim all that and have the wedge fitted in place. And this came out a little sloppy, but it's holding the blade real well. There's a tiny little bit of slack up around here, but it's adequate. And you get better with these as you go. And the other thing that I like to check on every once in a while is that the blade and the wedge should be basically right behind each other. There shouldn't be a shift in the blade and the wedge. They should stack up one right in front of the other. So that's locked up real good. And then Well, I'll take it out later. So now the other thing I can do here, which I probably won't show, is I'll just dress this up a little bit like on the original and taper that in. I don't think the curls come up that far. I think it's decorative more than anything else. It doesn't really affect the function of the plane. But this portion of the work is complete, and I had an idea what I may do, because these are going to probably be looking real close to each other. What I'll do is I'll stamp this one as an H for hollow. I'll put a light stamp on the wedge, and then on the other one I'll put an R for round. So now what I'll do is I'll go on to something else and take it from there. So I made a lot of progress with the hollow plane, and what I want to do now is start fabricating the round plane and bring it right up to where I have the hollow now, and then finish the project with both of them together. So in my previous video, what I did was I used the hollow plane to make the round, and it's a reliable way. I found it a little difficult, mainly because I felt that I had to get as much precision as possible into the round plane. And if I was making a piece of molding with the hollow, I could give or take a few thousandths of an inch, and if I put the piece of molding up on the wall, it might not make a heck of a difference. But in the case of trying to make one plane with the other, I think that's possibly a bridge too far. So I want to approach the fabrication of the round plane differently. And if you remember, when you saw me make the core box plane, in the description of that video is a simple statement. It's about as simple as you could possibly make it. And it's a statement. And it says, a plane with unlimited potential. And so I think that it would be appropriate to try and fabricate the cutting face of the round plane with the core box plane. So let's get into that. Now, first of all, let me say that I haven't done this before. So when you see me do this, this will be mocked up and fabricated by me for the first time. So if you're seeing me make this statement, you know that the project was a success, because if it's not, I wouldn't let you see this. I would have to approach it from a different standpoint. So let's look at the piece that I fabricated when I made the core box plane. The shape that it cuts is a semicircle. So what that means is that the width of the semicircle is twice the size of the radius of the semicircle. So if you cast a straight edge across the top and come right down through the center, this dimension right here is half of the combined. So this would be the radius of an entire circle, and this would be the diameter of an entire circle, and this would be the radius. So now let's apply the way the core box plane performs with this cut, and use this geometry as a rule of thumb to cut the face of the round plane. Now, the way the blank is set up, it's set up the same way as the hollow, so there's a shift in the cutting face of the plane is shifted to one side, the escapement side, just like the other one. So there's an extra 1/4 of an inch on the non-escapement side of the plane. So what we need to do is we need to create a channel just like this that the core box plane can ride in, right? Because it's guiding itself along these two these 2 points in order to sweep through and cut this curve. So what we have to do is we have to create offsets. So in the case of the 1-inch round plane, the part that's shifted to the side, I need to create another 1/2 inch of space. And then where there's already a 1/4 of an inch on the other side of that, the cutting face, that's already within the body of the plane, I only have to add another 1/4 of an inch to that. So I have 1/4 on that side, 1 1/4 inches for the body of the plane, and then a 1/2 inch on the other side, the escapement side of the plane. And that equals 2 inches, which gives me the 1-inch radius, which I want to be the cutting face of the plane itself. So I'm going to cut away and begin to start marking up a jig that allows me to use the core box plane and cut the face of that plane by following the governing rules of the geometry that I just described. I think it's going to be exciting. I think it's going to be innovative. I think it's going to be stimulating because of all the reasons I mentioned earlier, but also because the one thing that I like to do as far as this channel and plane making is concerned is to use planes to make other planes. And there might be a belief that the core box plane is archaic and unusable and not user-friendly, and I think we're about to see that that's not the case. So the most critical part of this jig is going to be these 2 straight edges that I fabricated. And what I'm going to do is nest a blank between these. This is just like 1x2, 1x3 pine. And I put in some, I made a rabbet and I put in some maple on the corner so it's more durable. These have been planed straight and been squared, but all the surfaces are trued. So these are going to be my straight edges, my guides for the core box plane. So what I do have here is I have 2 blocks that are going to elevate everything so that I can get the clamps around this. And let's see. Okay. So now the way the core box plane is going to sweep through here, I want to make sure that I'm going to use some steel plates to create the offsets. But I don't want the steel plates anywhere near where the blade of the core box plane is going to sweep through the blank. So what I did was I created a line 1 1/8 inches back from the corner, and that's where I'll start stacking some of this stuff. So I'm going to start with the face that has to be offset a 1/2 inch. So I have a piece of 1/8 inch steel here. I'll set that on those 2 lines. Then I have a 3/8 bar. So I'll stack that on top, and then I have a narrower bar, and that will sit behind it, and that will give me a nice flat surface for the blank. And that's going to be the escapement side. Okay. Now, on top of this, I already have the extra 1/4 of an inch now that's built into the body of the plane. So now I only have to stack a 1/4 inch on top of that, and I have a plate right here. So now if I put this straight edge back on top of it and mock this up, I believe what I'll have is a 2-inch opening between these 2 sections of maple, and this is right on 2 inches. Okay, so that will give me, this setup now will give me the 1-inch radius that I need with the blank in the proper position. So now the only other thing that I need to do is I need to place this blank in a certain spot relative to the front surfaces of the jig. So before I do that, let me put a straight edge right here, which is going to make it easier for me to line up the two straight edges. I'm just going to kiss the next straight edge right up against this winding stick that I'm using before I start creating offsets. Let me go ahead and do that. Okay, so what I did was I have the original round plane here, and I placed the steel plate over the cutting face, and with my my calipers, I projected down how much more from the bottom surface of this plate the middle of the cutting face extends below it. It's roughly 105 thousandths of an inch, which means, let's say, I want about 890 thousandths of an inch from the face of this to the face of the plane, and then the additional 110 thousandths of an inch will be the cut that I make inside the body of the plane. And I can go a little bit further, but I don't want to take off so much that the plane starts to shrink too much in size. So what I'm going to do is I'm going to place this on here like this, and I could, let's see, I'll use these clothespin clamps to hold this all in place. Okay, and then what I can do is I already have this all zeroed out and everything, so I know that I want okay, that's pretty darn close. So now what I'm going to do is I'm going to get some clamps on here and clamp all this together. Alright, let me get this set up and we'll take it to the next step. Alright, I got this mocked up. Let's give this a try. See how it works. Okay, we're going against the grain. That's making this a little tough. Okay, let's see how this looks with the straight edge. Looks pretty good. So what I don't like is that it cuts like a series of ridges, like it's a serrated edge. And I don't know if that's a function of something I'm doing wrong or the way that I don't have enough experience with this, but the radius is very, very nice. So let me hold that up to the camera and you'll be able to see how that looks. Do it from the other direction so you can see how that looks. Alright, that's your 1/4 inch offset here, your 1/2 inch offset here, the 1/4 inch built into the body of the plane, and your 1 inch radius right here. And you can see that the original bottom of the plane is very close to the termination of that radius, so I haven't gone down too far and just reduced the size of the plane. So the other thing I wanted to mention is, like in the past in my previous video, I did hollows and rounds up to, I believe it was a 1/2 inch. So in a case like that, it would be appropriate to use the hollows to make the rounds. If you started to get into, let's say, 1.5 or 2 inch hollows and rounds, I think it would be much more difficult to cut the rounds with the hollows. And you would want to do it like this. That's just my guess. I haven't done that. But that would be another compelling reason to develop this technique, so that as you started to get into larger planes or larger radiuses, inside radiuses for rounds, that you would want to do it this way. So what I'm going to do is take this all apart and probably sand that shape, but that's the working face. That's now going to be the working face for that plane. And so I'm going to take some time now, probably a week or two, bring this plane up to the other one, and then prep for the home run to finish both planes at once. And it'll probably be, who knows how many more videos. And then I'm going to do a test run with each plane. So that'll take some time. But in the meantime, I think this is a good proof of concept. And it was a great way to exploit the geometric boundaries of the core box plane.